Hey there. Welcome back. Section 2 continues. So we're on subsection 5. We're thinking about additional linear modeling. I kind of just wanted another modeling example, this time with a little bit of a different setup, because I know word problems can be such a struggle. It's nice to have some additional examples to draw from. So our two learning objectives here, one essential, which is to model a linear function, which is fit to do data points. So here, the sneaky part will be that our data points aren't officially like coordinates, x comma y, they're a slope and a point. Ooh, I'm giving it away, sorry, spoiler alert. And then we're also going to try to interpret the slope of a line. In fact, that'll be part of our building up process. Okay, so here's our example. So based on some real data, although making some real generous assumptions about the type of function here, beginning of 2020, Huawei had a 15% share of global smartphone sales. And then very, very roughly, because these things vary in not constant ways, but that share was rising at about 2.5% for every quarter that went by. So I'm phrasing it as quarter year here, just to be clear that we're talking about 1 quarter of a year. But typically it's just referred to as quarters. Samsung's global share was 21%, so higher global share at that exact same time, but it was falling by 0.5% per quarter. So our first task is to write formulas for market share for each of these two companies. Those are going to be as percentages, and then we're supposed to tackle, and then we're being told that in order to tackle this, we also need to know that they are linear functions, at least the ones that we're going to write. So very similar to the previous example, you might read through this and not get a whole lot out of it. So let's try to structure this the same way we did the biology example from before, where we look at what our goal is and then we reread and see if we can figure out what might get us there. So our goal in this case is a very similar setup to the aphid example we did before, but we are looking for linear functions, right? Write formulas for these two things as linear functions of time. So we need formulas for Huawei. If only I knew how to write letters. Huawei and for Samsung. So why don't we go with, say, h of t and s of t. And I'm making some assumptions here, but we can dig back in and see if those are actually good assumptions. So for instance, I made an assumption that little t would be a reasonable thing to use for our input variable. And I guess what I'm basing that off of is that these are linear functions of time, and so maybe the t isn't such a crazy thing to use for input. And then I just picked different function names because they are different outputs. These represent different companies, so we need different function names to represent them, and I've just picked the first letter of the company name. That seemed like a reasonable choice. You can pick whatever, because nothing is forcing you to pick a particular letter, variable names or function names here. And then the last piece of information that I think we could use maybe in our start to build our stuff we know list is that these functions are linear. So h of t is going to have some type of linear equation to it, and I'm going to use little subscripts on this one. I know not everyone's a fan, but usually this would be at plus b, but because we're going to have two different formulas here, then maybe we need to put little subscripts on this. So this one's are a1 and this is b1, and then for Samsung, then we'll have a very similar setup, but instead we'll just give it a little 2 subscript. So just because if we use the same letter A and B between both of those, then in theory within that same problem, maybe we're trying to talk about the same number for both of these, which we aren't. Probably these will have different values of A and different values of B. So we'll give them little subscripts. We'll get rid of that soon. So the fact that this is linear gives us this template to start with. If this one little word wasn't here, we would have no idea what to do with this because all we have are a couple of pieces of information from above. So let's see what we've got. So let's see. This company had 15% share, and that's right at the beginning of 2020. And I want to kind of accentuate this piece of it all the way through. So we've got the same phrase that appears pretty regularly. So for instance, at the beginning of 2020, shows up there. at the beginning of 2020, that exact same phrase again. And then as part of our set of directions after the beginning of 2020, this shows up yet one more time. So if we keep track of all those instances where this shows up, we can get something pretty consistent about these going. Give me my line. Thank you. Adobe, don't you play me like that. All right, we're not going to get to underline that piece. So what we're up to, oh sure, you'll make one over there. So this same phrase reoccurring throughout is trying to give us a little, it's always nice when we get to reuse this because it's going to tell us what what particular time is sort of our t equals 0. Because really you could pick whatever you want for a starting time, right? Is it 0, common era? Is it 0 hours after I buy pizza? Like what is it? So in this case, we're measuring time as numbers of quarters after the beginning of 2020. So t equals 0 is actually telling us about the beginning of 2020. So what's great is that these things match up. The t equals 0 is actually the exact same time snapshot that they give us. So what does that do for us? You can't answer because this is one way, unfortunately. But what that's doing right now is it's saying, look, this 15% is a value at t equals 0. So when time is 0, we're getting that the output, h of t, is 15. Now, okay, so one little aside. It does say 15%, which as a decimal would be 0.15. But our function is being measured as a percentage, so we're completing the sentence blank percent. So the 15 would complete that, would be that fill in the blank. So 15 is the output for this function. And then the same thing for Samsung, although let's see, that share was, so there's another piece of information. Oh, and then for Samsung, that their sales market share was 21%. So there's a little snapshot for them. So S of t was 21. And I guess there's yet more little bits of information that we can pull out of this. So every time you see a number, it is a math class, you'd be a little suspicious that that might be useful. So when we talk about Huawei, we see that that share was rising at about 2.5% per quarter. So this rising, that right there is classic slope. So it's rising at a constant rate. That's exactly what it means to be a slope. So rising at a constant rate is what is going to give us slope in both of these cases. So for Huawei, we're being told that A1, for instance, is, well, what do we get? Rising by, so it's positive because it's increasing, and this is exactly the units on our input and output, percentage per quarter. So this 2.5 is exactly the slope of this function. And then for Samsung, it's a very similar story, so that we're calling this A2. And let's see, for Samsung, now our description is that it is falling by about 0.5% per quarter year. Well, okay, so that's still a slope, it's just a negative slope. The units still match perfectly, it's still percentage per quarter, those are exactly our output and input units. And then it seems like we've got a whole lot more to do here, but here's the thing, our units, our constants here, we've actually found them both. So t equals 0, usually we would think about it plugging in a point, but because this is t equals 0, this value is exactly 15. This constant is 15. That's what this y-intercept or vertical axis intercept is really going for. When t equals 0, b equals this number. And then the exact same thing for Samsung in this case. And so actually we're done. It seems like we just finished cataloging all this information, but now we can actually put both these things together. A1 is 2.5. We have our time. And then B, because we happen to be given the value right at the beginning, that's important. If it's not just any point out there, this won't hold. But because it's at t equals 0, this is exactly our value of B. And then the same thing holds for Samsung. We have a slope of -0.5 and a vertical axis intercept of 21. Okay, so there is, and maybe we can get ourselves some not red victory boxes. What are we going to do? We're going to do a little gold. Let's try that. Yeah. Oh, come on now. I was afraid I'm going to put some like rivals school colors down and get angry messages from you. No orange and black circle things. What do we got? Oh, I guess we have UCLA here right now. Sorry. Oh well. Okay, last question for this setup. When do the models predict that Huawei's market share will exceed Samsung's? So if we're setting up goal stuff here again, I think mostly what we are looking for is where does one function kind of pass the other one? So let's see, it's Huawei's market share is h of t and Samsung's is s of t. And so math-wise, we are looking for when this function becomes greater than that. This function represents the market share for one company. This represents the market share for the other. The greater than symbol. We're solving. We're trying to figure out what values of the input might get us there. So we're just going to solve. We have formulas for both these things. We can make this happen. So h of t was our left side. S of t is our right side. And now we just have ourselves a good old-fashioned math inequality to work with. So we could add 1/2 t to both sides. We could take away 15 from both sides. And I think if we divide by 3, we get ourselves a nice number. Okay, so because this question was phrased in words, it's always nice to go back to that before we're done. So t greater than 2 is fine, but I guess I have to take a moment and think. So t was measured in number of quarters after the beginning of 2020. So if t is 2, then we're 2 quarters after the beginning of 2020. So this is after the second quarter of 2020. So this, and if I want to make this a complete sentence, Huawei's market share will exceed Samsung's. That's a big bold claim. Please do not put money down on that claim. In part because one of the claims here is pretty dubious, that these functions are always linear. So just because we see some temporary trend in this behavior, all you got to do is look back over a longer period of time and you see lots of fluctuation in market share. So this was a huge math assumption that we made in order to get progress made, but we made it because linear functions are great and it's kind of one of the easiest things to put together. So right, do not be putting money down on Huawei surpassing, which I guess at this point would have already happened. Okay, so the other thing I want to that we're being asked to address here is how does, give me my line back. How does this look geometrically? Like, what does it mean to have come up with this this place where one function crosses the other, basically? So I think we can make the good argument that we don't have to focus on the positive or anything except for the positive quadrant where both the variables are positive. I guess the argument there is, if we're thinking about time, maybe you could look back in time. That seems reasonable, but the time that we're focused on is not negative, so maybe it's not all that important. And then the negative outputs would mean the negative market share, and that seems a little odd too. So we definitely have t for the horizontal axis. For the vertical, we can kind of make up our own variable. I don't want to write either h or s because each of these functions is sort of its own way, using time in a different way to get some output. So we need some other variable. We haven't named it yet, so q is kind of my laziest default. So I guess what I might do is try to put some labels on here that will get us a picture of what's going on. So if each tick mark is 3, so that's 3, 6, 9, 12, 15, 18, 21, 24, something like that. And then our horizontal values, I'm using my thoughts about the functions themselves, because I know this starts at 15, this one starts at 21, one goes uphill, one goes downhill, so I'm just trying to sort of gauge based off of what I know, what kind of axis measurements might make some sense. So for instance, we know that when we're looking at Huawei, for instance, that at t equals 0, we're at a height of 15, which gives us a great starting point. I guess I used okay, so we'll pick whatever color we want for these. So 15 puts us right about there. And then using that slope to get new points is always kind of fun. So that means every time we go over 1, we go up 2.5. So in my scale, that's a little odd, but that puts us just short of 18 after 1 quarter has gone by. And then we're up another 2.5 by the time we do that. So we're here-ish. And then the function would just keep on keeping on in that fashion. So our linear function then that connects all those things might look something like something like this. So obviously my lines aren't perfect, but hopefully you'll forgive me. And then presumably it keeps on going, and you know, who knows how long this is applicable for? Probably a really short time frame, honestly. But we can call this q equals h of t, so all the q values that sort of match up with Huawei's function. And then if we do the same thing for Samsung, Samsung's market share is starting at a height of 21, so I guess that's up here instead. And then every time we go over 1 unit, it goes down half a unit. So that's a little hard to measure on here, but I guess by the time we've gone over 2, it's gone down 1 unit, which I think we actually have kind of a spoiler about. And then let's see, another 2 units over would be another 1 down, so it's really not moving very rapidly. And then what we might get out of this is something like, again, we can kind of extend it beyond the edges there, even though that's not, you know, it maybe doesn't make a whole lot of sense for the function itself, but something like that for what our outputs might look like. Okay, so I'll put arrows on there, and we can say here's q equals s of t. But who knows for how long this is mathematically useful. However, you can kind of see the interesting thing that happens at t equals 2. What we've discovered basically is the intersection of these two functions. So graphically, or geometrically, another way to phrase that, what we've done is, so t equals 2 is the intersection of functions. So the intersection of the two graphs. So that's what's going on from a visual perspective. As soon as we pass t equals 2, the blue line is higher than the gold line. And so this one will continue to have larger and larger market share, and the other will continue to fall. So there's some linear modeling from a different perspective. Here we started out not with 2 points, but with basically a point and a slope. And then we had one additional bit of excitement where we used those two linear expressions to try to solve an inequality. Could have been the same for equal sign if we wanted to figure out when the market shares were equal to one another. Okay, we'll be back with one more subsection for section 2. We'll be talking about some piecewise defined linear functions. See you then.